Hello and welcome to your week 7 lab. In this video, I'm going to go over the lab 7 assignment where you are going to work on your data and cleaning your data just like you did last week. And then you're going to actually create a data dictionary for your data. So all of the work today will center on the data that you have collected through your survey in Google Forms. So the first thing you're going to do is you are going to download the responses that you got in your Google Forms survey. You're going to download those in an Excel document from Google Forms. The first thing you should do when you download your data into the Excel document is make sure you delete all the pilot data that you collected from your survey. So when we did the pilot testing during lab, please delete that data. You're not going to want to use that data for your actual analysis. So please remove that from your Excel document before you upload that into your JMP file. For your lab assignment, you're going to submit 3 files as outlined in the actual instructions posted to Canvas. Please make sure to pull up that instructions document in Canvas under the week 7 lab. So for this lab, you're going to submit 3 files. You're going to submit the raw data saved as an Excel file. So that data that you download in Excel format from that Google Forms survey, in terms of that data you collected, you're going to download that data in Excel. You're going to remove the pilot data and you're just going to leave the final data in there and just save that document, and that's going to be the first document that you submit with your lab. It should just have all of the raw unedited data that you collected through your Google Forms survey with the questions at the top. You're not actually making any edits to this Excel document other than removing that pilot data. The second document you need to submit is an edited spreadsheet saved as a JMP file. So we're going to talk about that in just a moment, but this second document is going to be an actual JMP file that includes your original data and then some new variables that you create. And then the third document is going to just be a Word document that you create that justifies why you created any new variables, did any kind of recoding. It's also going to have a table that shows the distribution of all your variables of interest, which we'll go over. And then it's also going to include the data dictionary for your data. So as a reminder, your file 1 is just going to be that Excel document with the data that you downloaded from Google Forms with the pilot data removed. You'll submit that as file 1. Now file 2 is going to be an edited JMP spreadsheet in a JMP file. So you're going to basically take the data, excluding your pilot data, you're going to take that remaining data and you're going to import that into your JMP software. So in this second file, you should have the original variables that you got from that unedited, that Excel document, and then any newly created variables that you decide to create during your lab today. Before you start recoding anything, you have to actually code your data. So what you need to do is that you need to make sure that all of the data displayed in your JMP file, the actual data, is coded in numerical values. It should not be displayed in any kind of character format. And the reason for that is when you typically get a data file, it's going to be in numbers. It's going to be in numerical format. It's not actually going to contain text in those responses. So let's look at an example. Let's say that one of the variables that you collected in your survey was biological sex. So you asked people whether their biological sex was female or male. So this on the left might be what your data looks like when you import that from that Excel document into your JMP software. You cannot leave this variable like this. What you need to do is you need to make sure that all of your original variables are coded. When I mean coded, it means that you've removed this actual text here and you have assigned them numbers. So for example, in this example on this slide, my data dictionary would show that zeros are equal to female and 1 is equal to male for the variable biological underscore sex. So please make sure that for your biological sex variable, if that was a variable in your data set, you're not submitting a file that shows this. You're submitting a file that shows this original variable. This is your original variable in its original form, but it has numbers assigned to the values. It doesn't have characters. So all of your variables you submit in your JMP file should all be displayed as numbers, not as characters. So make sure that when you submit your file, so if you're looking at just this biological sex variable, you should not have 2 biological sex variables, one with text, one with numbers. You should just have 1 biological sex variable that is coded with numbers. And remember, to do this and to actually code your data, you're going to need to use that recode function in JMP, just like you did last week. So for file number 2, you'll need that JMP file. Make sure all of your variables are named according to best practices. So you shouldn't have the actual questions that were asked in your survey in the JMP file. You should have really short, meaningful names for the variables. They should be following best practices. So for example, you shouldn't have spaces in there. You should have underscores in place of those spaces. So please make sure you've reviewed the best practices for naming variables. Make sure all of the variable types are specified correctly for your entire data set. So make sure that they say if they're ordinal or they're nominal or they're continuous, they need to be specified correctly. In this second file, in this actual JMP file, besides naming your variables according to best practices and specifying the correct types, you need to look at all of your variables of interest. So your independent, your dependent variable, and your potential confounders. And you need to look at them in terms of the distribution, just like you did last week. You need to look at them and decide whether you're going to actually recode them. So not code them. I'm not referring to coding. Coding would just be putting numbers assigned to these character responses here. What I mean by recoding is that I have a question that maybe has multiple categorical responses and I'm collapsing those. So for example, last week you had the HUQ010 variable and there were several categorical responses for that variable, which indicated general health condition. So you had excellent health, good health, and then you had something like fair health and then poor health. That was your original variable and it was assigned numbers. Then you recoded that variable into the HUQ010 dichotomous variable. So when you did that, you had to make a decision based on what you wanted to display or show, which was poor health versus better health. And you looked at the distribution of that data to make that decision. And then you decided that based on the distribution of that data, I'm going to combine the categories of fair health and poor health to create the new category, poorer health. And then the other values for the excellent and good health, you then combined into the category of better health. You're doing the same thing now for your variables of interest, your independent variables, your dependent variables, and your potential confounders. You need to look at the distribution of that data. You need to make sure that there aren't any categories with really small numbers of responses. If there's any categories with small numbers, you need to figure out how to collapse those. Also remember your outcome variable needs to be a binary or dichotomous variable. So it needs to have 2 options. If you have a continuous value for your outcome variable at this point, this is when you should decide during this lab, you're going to look at the distribution of that data and then decide how you're going to make that variable dichotomous. So you might need to think about what threshold you're going to draw, and then say anyone above this value has a high level of X and anyone below this value has a low level of X. So you have to look through each variable and make decisions about how you're going to code those variables. You cannot leave the variables by themselves in small numbers in categories if those categories have really small numbers in them. Also remember, anytime that you are coding your data, so just assigning numbers to character responses, or if you decide to recode data, so maybe you've got responses from 1 to 5, so you've got people who are 1s, 2s, 3s, 4s, and 5s, and you decide to make that a binary variable where you code people who are 1 to 3 as 0s and people who are 4s and 5s as 1s. Regardless of how you code or recode your data, you need to keep track of what you're doing. And so please make sure, we'll talk about this in the next slide in file 3, please make sure every time you recode a variable, you are updating that in your data dictionary to keep track of what you've done. So your third file is going to be a Word document that is going to include a justification for any new variables or any variables that you recoded. So I'm not referring to variables that you just code. So for example, the biological sex variable was male and female. You assigned females the value of 0 and males the value of 1. That's just coding your data. If you've recoded your data, so for example, you took the HUQ010 variable that had maybe 4 or 5 responses and you created a dichotomous variable for that, the HUQ010 dichotomous to indicate better or poorer health. That variable, that HUQ010 dichotomous variable, remember you justified in last week's lab why you decided to make that decision and how to recode that variable. So you should justify based on what it is you're trying to show with your variables and also the distribution of the data in that variable. You should think about what your justification is, and you should write up your justification. So make sure you're starting this by looking at the distributions for each variable so you can think about making informed decisions. Remember to have your missing values coded if you have any missing data. Make sure they're coded in a way that's not going to get confused as an actual value. And remember, don't forget your outcome variable has to be binary. So make sure that you include a justification that's well reasoned, it's complete, and it's clear and easy for me to understand. So that was part A, that justification. In part B, you're going to include one table that shows the distribution of all the variables of interest in your data. So you need to have the variables for your independent variable, the variable or variables for your dependent variable, and also the variables that you're looking at as potential confounders. These need to be in their original and categorized forms or recoded forms. So if you remember, the table you created last week for the HUQ010 variable, you started that table with the HUQ010 variable and you had all of the n's and the percents for each one of those categorical responses. And then you had the HUQ010 dichotomous variable. And in that one, you had the n and the percent for the poor health and the better health. So you had both of those variables, both in their original form and then their recoded or their recategorized forms. So you need to include your variables in their original form, and then any variables that you've recoded, you need to include those variables in their recoded form as well in the table. You'll just insert rows to add more rows to that table and add in the information. Exactly the same, you can follow the same template or format as the tables from the table from last week. Now remember, when you're displaying your variable information, if you have a continuous variable, you should be using the mean and the standard deviation. And if you have a categorical variable, you should be displaying the n and the percent. So your table should include all of your relevant variables. It should be easy for me to identify your independent, your dependent variables, and your potential confounders. You need to present all the distributions correctly, and then it needs to be neatly formatted. So again, follow the formatting from your lab last week. And then lastly, you are going to create a data dictionary for your data. So please use the format from the data dictionary from your lab last week. Use that as the template for your data dictionary for your variables. So remember, your data dictionary should be in alphabetical order. It should include all of the variables in your data set. All of the variables in your dump file, they should appear in your data dictionary. Again, please follow the format that was provided from the lab last week, and you need to provide correct information for all of the variables, especially if you've created any new variables or you've recoded original variables. You need to state the name of the variable from which the other or the new variables were derived. So please make sure that that isn't missing in your lab. If you have any questions, please feel free to email me directly, or you can come to my office hours. I'm happy to answer questions on this lab.